Picture this. You're standing on the edge of the African savanna. The air is, thick and humid. The sun is just beating down on you. And a herd of elephants is moving slowly through the tall grass.
Right. Just a totally peaceful, normal scene.
Exactly. But suddenly, one of the elephants stops dead in its tracks. It lifts its head, its ears flare out, and it responds intensely to this low-frequency rumble that just rolled across the plains. But here's the thing. None of the other elephants reacted at all.
Oh, wow. Because it was meant just for them.
Yes. That specific rumble was directed entirely at that one elephant. They aren't just hearing some random animal noise in the background. They're hearing the elephant equivalent of their own name.
When you really stop to consider the implications of a scene like that, it fundamentally shifts how we view the natural world.
It really does.
Because for centuries, traditional knowledge, folklore and indigenous traditions have hinted at these deep, complex inner lives of animals. The idea that they have their own cultures, their own names, their own mysteries that our human senses simply couldn't perceive. And now the rigorous science is actually starting to catch up to that intuition.
It is completely blowing my mind. Welcome to another My Mind MashUps deep dive where we unravel mysteries, spark curiosity, and make sense of complex ideas together.
We also want to take a quick second to thank our coffee supporters for helping fund the research and creation of the show.
Absolutely. And thank you to you, the listener, for sharing part of your day with us. If you enjoy content that makes you think, follow, or subscribe wherever you're listening, you can also like, share, or leave a comment to help more curious minds discover the conversation. If you would like to support the channel directly, the link is in the description.
So today's deep dive, we are exploring the really explosive intersection of artificial intelligence and animal communication.
Right. We're looking at a massive stack of new research dossiers on the table today. We're analyzing breakthroughs from Project CDTI, the Earth Species Project, and a whole slew of peer-reviewed papers with an evidence cutoff of August 2026.
And the mission for today is straightforward, but honestly, massive. Are we actually on the verge of a universal Dr. Dolittle translator, or is the commercial hype masking a much more complex reality?
It is a critical question. And to figure out where we are going, we first have to understand the mechanical shift that just happened in biology. We are currently living through this acoustic data avalanche, and AI is pretty much the only tool keeping us from drowning in it.
Yeah, because for decades, field researchers had to do this the agonizingly hard way.
Right. I always picture a grad student sitting in a humid tent somewhere, wearing these heavy headphones, manually listening to tapes, just hitting pause and play over and over, trying to pick out a single bird call over the sound of the wind.
Exactly. And that human bottleneck severely limited what we could actually discover. But today, the shift to passive acoustic monitoring changes everything.
Right, because we just leave the microphones out there.
Exactly. We have hydrophones continuously recording in the oceans, microphones strapped to jungle canopies, biologging tags actually on the animals themselves. We are capturing more audio in a single month than a human being could review in an entire lifetime.
Which is exactly where AI enters the chat. The dossiers highlight these foundation models, like the Earth Species Project's Natural LM Audio. To understand this, think about how large language models work for text. They predict the next word based on billions of examples, right?
Right, like how autocorrect works, but on a massive scale.
Exactly. Well, these audio foundation models are doing something similar, but with raw sound waves. The way the sources describe it, it is essentially giving researchers superhuman hearing. The AI acts almost like a sonic prism.
Oh, I like that framing. How do you mean?
Well, if you think of a glass prism taking a beam of chaotic white light and separating it out into individual clean colors, well, that's what this AI is doing to sound. You feed it a chaotic wall of jungle noise, and the algorithm bends and separates the audio streams.
Oh, I see.
Yeah. It strips out the howling wind, it isolates the rain hitting the leaves, and it pulls out a pristine audio track of two overlapping callers, separating them perfectly.
And the precision of that filtering is exactly what enabled the recent massive discoveries. Because without it, we wouldn't have the 2024 sperm-whale study by Project CET.
Right.
Because of this technology, they didn't just analyze a few hours of tape. They ran over 8,700 sperm whale codas through machine learning.
And just to clarify, a coda is a specific pattern of clicks, right? Almost like Morse code.
Yes, but what the AI revealed is that it's far, far more complex than simple Morse code. The machine learning models mapped out a highly contextual and combinatorial structure.
Okay, what does that actually mean in practice?
It means the whales are actively using rhythm and tempo. They also use something called rubato.
Wait, rubato? Like in classical music?
Exactly like in music. Rubato is this intentional, expressive variation in timing. Imagine a jazz musician slightly delaying a beat to build tension, or lingering on a note for emphasis.
No way. The whales are doing that.
The whales are doing that with their clicks. And they also use ornamentation, so they add these extra rapid clicks to the end of a coda. The AI essentially proved that they aren't just making fixed, instinctive sounds. They have a combinatorial coding system.
So they mix and match all these elements.
Exactly. They mix and match rhythm, tempo, rubato, and ornamentation entirely, depending on the context of their conversation.
That is wild. I mean, it's easy to imagine how complex sound structures evolve in the ocean, where sound travels for miles and you really rely on it to survive. But does this complexity exist on land, in more immediate environments?
It definitely does.
Yeah, and that's where that 2024 elephant study comes in, which ties right back to our opening scene. Researchers took recordings of wild African savanna elephants and used random forest machine learning models to analyze the acoustic structure of their rumbles.
Right. And for you listening who might not be data scientists, a random forest model is essentially a massive committee of decision trees. Think of it like thousands of individual algorithms all looking at the exact same elephant rumble and voting on who they think the sound is meant for, just based on tiny acoustic features.
And the voting committee was right. The AI was able to predict the intended receiver of a call just from the sound wave itself.
That is just incredible.
It is. Then the researchers did the ultimate test. They played these calls back to the wild elephants. The elephants responded much more strongly, lifting their heads and moving toward the speaker when they heard calls originally addressed to them.
Which proves they are using non-imitative, name-like calls.
Exactly. They aren't just copying the sound their friend makes to say, "Hey, you." They have invented a unique, abstract label for that specific individual.
The leap in cognitive complexity there is just profound. If you connect this to the broader animal kingdom, bottlenose dolphins have been known for years to use signature whistles that convey identity.
Right.
They will even copy learned whistles to address a specific dolphin in their pod. So across dolphins, elephants, and sperm whales, we are seeing these intricate, culturally transmitted, identity-driven communication systems. It completely shatters the human-centric assumption that we are the only species capable of structured information sharing.
Okay, but here's where it gets really interesting, where I think we need to apply some friction to the hype. Finding a pattern is not the same thing as finding a dictionary.
That is a very important distinction.
Yeah, there is a brilliant analogy in our sources about the limits of just using audio data. Training an AI only on acoustic recordings is like forcing a human translator to decipher a complex conversation while blindfolded in a soundproof box.
Oh, that's a great way to picture it.
Right, because they can hear the voices perfectly, but they have absolutely no idea who is in the room, what just happened right before the people started talking, or what physical gestures they are making.
The blindfold analogy gets right to the heart of the problem. Because animal communication is deeply, fundamentally multimodal. It's not just a radio broadcast, it's a full-body experience.
Oh, the body language.
Exactly. A honeybee waggle dance relies on movement, the odor of the flower on the bee's body, and the vibration of the comb. A cuttlefish communicates through shifting skin patterns, posture, and water vibration. Even the elephants we just talked about are using ear flares, trunk postures, and touch to communicate while they rumble.
So if we just feed an AI the audio file, we're essentially hiding half the conversation from it.
Precisely. The AI has proven these animals have vast, mathematically structured repertoires. But, and this is a critical reality check for everyone listening, all this massive computing power hasn't given us an English translation for a single sperm whale coda.
Not one.
Not a single one. We know they're having complex exchanges, but we are completely locked out of the meaning.
Which feels like the perfect bridge to talk about the translation ladder. Because the research dossiers outline this really fascinating 9-step scale to help us understand where we actually stand, rather than where the sci-fi headlines claim we are. Let's walk through this slowly because it clarifies so much.
I think the latter is the most useful mental framework in the entire dossier. So rung 1 is the most basic, just detecting a sound, knowing that an animal made a noise.
Right. And then rung 2 is diarization, which is a fancy way of saying we can separate who made the sound, knowing that whale A clicked and then whale B clicked back.
Moving up, rung 3 is organizing recurring units. The AI realizes that a specific 5-click pattern keeps happening. Then rung 4 is grounding it to a context. We noticed that the 5-click pattern always happens right before they dive for food.
Okay, making the connection to the real world.
Yes, and this ladder goes all the way up to rung 9, which is the Holy Grail, a fluent, two-way, semantic conversational dialogue with another species.
Okay, so looking at this 9-rung ladder, where are we actually sitting right now?
We have one foot firmly planted on rung 3, and we are heavily struggling to pull ourselves up to rung 4.
Oh, wow. So nowhere near rung 9.
Not even close. We are incredible at organizing the data. The AI can find the patterns perfectly, but grounding it to actual context is agonizingly difficult.
It's funny because if you read the public conversation or scroll through tech blogs, people frequently jump straight from rung 3 to rung 9. They see a headline that says, AI maps whale clicks, and assume we are months away from asking a blue whale about its childhood.
The discrepancy between public expectation and scientific reality is just massive right now. And the primary reason we can't just leap to rung 9 is this grounding bottleneck. Think about how we train AI to translate human languages. We use parallel texts.
Like a Rosetta Stone.
Exactly. If you want a machine learning model to translate French to English, you feed it millions of documents, like United Nations transcripts, where the exact same meaning is written in French and English side by side. The AI compares the two and learns the map.
But, I mean, no whale is ever going to hand us a parallel text. We don't have an English transcript of their clicks.
That's the bottleneck. Without a Rosetta Stone, researchers have to infer meaning entirely by correlating sounds with observed behavior. And then they have to somehow prove that their inference isn't just a coincidence.
Okay, let's unpack this a bit more because I want to push back on that. If an AI model analyzes 10,000 hours of drone video and hydrophone audio, and it captions a specific sound as a feeding call with 95% confidence, I mean, isn't that translation? It watched them eat, it heard the sound, it put 2 and 2 together.
It feels like translation, definitely. But the danger of that illusion is exactly why the scientific community is so cautious right now. This is where we run into the strongest skeptical argument in the sources, a phenomenon called context leakage.
Context leakage. Okay, what exactly is the AI leaking?
It's leaking artifacts from the data. AI models are essentially prediction engines, and they are famously lazy. They will exploit any hidden pattern in the recording just to get the right answer. So imagine your AI classifier confidently predicts a feeding call. It might not be recognizing the animal's feeding vocalization at all.
Wait, really? What else would it be recognizing?
It might just be recognizing the low-frequency hum of the research boat's engine that happens to be present every single time the researchers follow the whales to their feeding grounds.
Oh, wow. So the AI is basically just saying, I hear the boat engine, therefore they must be eating, and we pat ourselves on the back thinking it decoded the animal's language.
Exactly. It is the modern silicon version of clever Hans.
Oh, I know this story. The horse.
Yes. Remember the horse from the early 1900s that everyone thought could do math? People would ask him what 5 + 3 was, and he would tap his hoof 8 times. But he wasn't doing math. He was just reading the subtle, unconscious body language of his trainer, who would slightly tense up when the horse reached the right number of taps.
That is wild. And today, the AI is clever Hans, and the boat engine is the trainer's body language.
Precisely. When an AI confidently outputs a fluent English caption like, "Where are you, sister?" it creates an incredibly dangerous illusion of certainty. We want to believe it so badly. But that label might just be a probabilistic guess based on the mere fact that 2 female whales are in the same recording.
And before we get into how researchers are trying to solve that problem, if this conversation is making you think, follow or subscribe so you don't miss the next My Mind MashUps deep dive.
So getting back to it, how do we get past the clever Hans problem?
Right, because if we can't blindly trust the AI's assumptions due to this context leakage, how do we actually prove what a call means in the real world? The only logical mechanism I can think of is playback. You have to take the isolated sound, play it back to the animal, and see what they did.
That is the scientific standard. On our translation ladder, that moves us to rung 6, which is testing causal meaning, and eventually rung 8, which is generating a reply. You put a speaker in the jungle or the ocean, play the specific click or rumble, and observe.
Do they search for a predator? Do they approach? Do they flee?
Exactly. But doing that in the wild, well, the sources highlight that this is an absolute ethical minefield.
I can imagine.
It introduces severe animal welfare risks. Playback experiments can frighten animals. They can distract them from feeding. They can deceive them into abandoning a safe area or even separate mothers from their young.
That's terrible.
It is. Think about it. If you play a distress call just to see what happens, You are intentionally causing immense psychological stress to that animal. If you play a territorial call, you might trigger a violent fight or cause a group to abandon their critical habitat entirely.
Which creates this agonizing barrier to the research. You need playback to prove the translation, but playback can actively harm the subjects. And this gets even more intense when we look at generative AI. The dossiers mentioned that the Earth Species Project analyzed 1.5 million zebra-finch vocalizations to create an AI model capable of extended real-time interaction.
Yes.
They are building systems that can essentially sustain a vocal exchange with a bird. If I'm listening to this, I'm immediately wondering, well, if we have an AI that can generate these sounds perfectly in real time, why aren't we just dropping smart speakers into the jungle and letting the AI figure out the language through massive trial and error?
And that raises an incredibly important question about the dark side of this technology. We have to talk about dual-use risks.
Meaning the technology can be used for good, but just as easily weaponized by someone else.
Exactly. If you build a generative AI system that can reliably call an animal or perfectly mimic its mating call or its distress signal, that exact same open-source model could be downloaded and weaponized by bad actors.
Like poachers.
Yes, exactly. Poachers could use synthetic playback to lure endangered species, like a specific elephant or a rare bird, right into a trap.
Oh, that is so bleak.
And it goes beyond poaching. Commercial fishing ships could use these acoustic lures to manipulate the movements of fish or whales to maximize their catch, entirely disrupting the local ecology.
Wow.
The scary part is that the label of giving animals a voice hides the terrifying fact that humans are the ones controlling the microphone and the response. It strips the animal of its agency. Instead of being a bridge for empathy, the AI becomes a tool for manipulation.
That is deeply unsettling. It's one thing to be a passive listener, trying to learn and appreciate their inner lives, but it's a completely different paradigm to hack into their communication network and start spoofing their signals.
Changes our relationship to them entirely.
It really does. So factoring in the grounding bottleneck, the context leakage, and the massive ethical risks of playback, let's look at the concrete forecasts outlined in these dossiers, the 5, 10, and 25-year projections. Are we ever getting this universal translator?
The scientific consensus in these papers offers a stark reality check, honestly. Within the next 5 years, by 2031, we will see vastly improved cross-species detection. We'll be able to identify callers, track populations, and categorize contexts faster and more accurately than ever before.
Okay, so vastly better monitoring. What about 10 years out?
Within 10 years, we might have credible, limited functional glossaries for a few very well-studied species. We might know exactly which specific calls coordinate group movement in a particular dolphin pod, or which rumbles signal a specific type of danger for an elephant herd.
But no philosophical debates about the nature of the ocean.
No, definitely not. And even looking 25 years out, the idea of a universal pet translator that tells you exactly what your dog is thinking in complete, nuanced English sentences is highly, highly unlikely.
Though I'm sure we'll see a dozen commercial apps launch next month claiming to do exactly that for a monthly subscription.
Oh, without a doubt. The commercial space will be flooded with marketing hype, but it won't be validated science.
So what does this all mean for us? If we aren't getting the Dr. Dolittle earpiece anytime soon, is all this AI bioacoustics work just an academic exercise? I was reading the optimistic case in the sources, and it struck me that perfect semantic translation isn't actually required to fundamentally transform our relationship with the natural world.
I completely agree with that.
Yeah.
How do you see the transformation playing out?
Well, if the AI can just become hyper-reliable at detecting the context of a sound, distress, separation, pain, or just the physical presence of a specific animal, that alone changes the world. We don't need to know the whale's deep philosophy on ocean currents to know we shouldn't run it over.
Exactly.
If an AI buoy detects a sperm whale coda, ships can automatically reroute to avoid a strike.
And that application extends far beyond whales. Conservationists could use these acoustic nets to detect when keystone species is shifting its habitat due to climate change long before human observers could spot it on the ground.
Oh, that's a brilliant use for it.
Right. And farmers and veterinarians could run continuous acoustic monitoring to identify welfare problems or respiratory distress in livestock instantly, treating diseases before they even spread.
It's basically the ultimate early warning system.
It is. But we have to acknowledge that even that level of passive monitoring requires strict governance. There is a crucial section in the dossier concerning data sovereignty. A significant portion of these massive acoustic datasets are being collected on indigenous lands or in local communities.
Right. The data isn't just floating in a void, it's coming from someone's backyard.
Exactly. And this acoustic data shouldn't just be extracted by well-funded tech companies or universities without co-governance, benefit sharing, and a deep respect for the cultural context of that area. Often, traditional ecological knowledge has recognized the complexity of these animals long before Western science trained an algorithm to prove it.
And there's the concept of ecological privacy, too. I mean, a microphone in the jungle doesn't just record birds. Continuous listening in the wild captures everything.
It really does.
It captures the animals, but it also captures human activity, private community movements, conversations. It's essentially a massive, unblinking surveillance net.
Which is a profound ethical challenge. Just because we have the technological capability to deploy AI to listen to every corner of the forest doesn't automatically mean we have the moral right to do so, without strict binding limits on who owns that audio data and how it can be weaponized or monetized.
So to bring this all together for you listening, AI is not handing us a magical English dictionary for the animal kingdom. We aren't going to suddenly translate a dog's bark into, "I love you, let's go for a walk."
Sadly, no.
But what this technology is doing is acting as a massive accelerator for biology. By crunching data at a scale humans simply cannot achieve, it is proving beyond a shadow of a doubt that species like sperm whales, elephants, and dolphins use incredibly complex, combinatorial, and identity-driven communication systems. They have their own rhythms, their own names, and their own intricately structured societies.
And that leaves us with a final, lingering question to mull over as we watch this technology evolve. If we do eventually crack the code, if decades from now we achieve a deep, partial understanding of the communication of other species, will that knowledge actually bring human society closer to nature, fostering a new era of empathy and coexistence? Or will it just make nature easier for us to manage, monitor, and monetize?
That is the exact tension we are going to have to navigate in the years ahead. Share your thoughts with My Mind Mashups on our social platforms. Your perspective could help shape a future deep dive.
If you enjoyed this deep dive, like, share, follow, or subscribe wherever you listen. You can find My Mind Mashups on YouTube, Spotify, Apple Podcasts, Amazon Music, Audible, Facebook, TikTok, Pocket Casts, and wherever you listen to podcasts.
We didn't come this far just to come this far. This is My Mind Mashups.